All right, welcome to lesson 5.3. It's called More Movement. Let's translate graphs vertically. So vertically is up and down, right? And horizontally, which is right and left, to match situations. Here's the warm-up. This is on page 539. So we look at A and we see how it's moved. How it's moved left and right or up and down, or a combination of the two. So F would be a combination of the two, wouldn't it? So the way that I do this is I look for a key point. So this would be a key point for me because it's going up and then right there it changes to just going over. So that's a key point. So the key point on E would be right there. So we're comparing A to E. Well, that's easy to do. You're just going, that's right, up 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So 6 up. All right. This one is just going over. So it'd be to the right. Over to the right. How many? 2 to 8 would be right 6. And you can go through, and this would be a combo one, wouldn't it? So it's right 2 and up 1, 2, 3. Right 2, up 3. All right. So here's the bakery one that we did, and this is the second crack at it. All right, so this is the same thing where we had the temperature of the building, and then you turn the heat on, or actually the oven's on, it gets hotter, and then it gets cooler. And then we shifted it 2 hours earlier. Yes, 2 hours earlier. So this was 5 o'clock in the morning, and then it became 3 o'clock in the morning. So we shifted it 2 hours earlier. It says down here, Andre thinks when it's 2 hours earlier, that means we need to subtract 2. No, we actually need to add 2 because it's moving it to the left. The graph is going to the left. So here's how you think about this. This point right here is G of 4. G of 4 is equal to 85. All right. So up here we have H of 6 is equal to 85. All right, so how do we convince ourselves to add 2? So we say G of X is equal to, in order to get, if this is 4, we add 2 to get 6 in order for these to be the same. So for these to be the same, we have to add 2 to 4 to make it be 6. So let me say that again. For these to be the same, we got to add 2 to 4 to make it 6. So that's why it's H of X plus 2, not minus 2. I didn't need that parenthesis there. All right. Now it says, what did the owner do here? So for this graph compared back to this graph of H. Well, it's 5. Well, 5 became 6 is the first thing I noticed. So 5, so it went 1 to the right. So at right 1 hour. And then it was 65. It went up. So it went up 5 degrees Fahrenheit. So we started off at 70 instead of 65. So the answer to this is write expression F. Expression for F in terms of the original H. So F of X is equal to H, so it's right 1, so it's going to be X minus 1, that's right, and then it's going to be up 5. And there we go. All right, this next example is about thawing meat, which is kind of the opposite of like taking something warm and putting it in the refrigerator. This is taking something cold and setting it outside, or setting it out, so it's going to get warmer. So we want to fit the data here. This is the original data for the meat, so that's what it's coming out as. This is in degrees Fahrenheit, so it's 13 degrees Fahrenheit when it comes out of the freezer. and then it warms up to 45 degrees Fahrenheit at, this is hours, so basically 5 hours later. So the graph is like this. Here's the g function down here, and if we take this g function and we move it over, we can make it into this data. So Jada says, hey, what we need to do is we just need to move it up 75. So she just says take it and move it straight up 75, and it'll match there pretty closely. And Noah says we need to go up 68, but then we need to go how much? 1 hour to the, 1 left. Because remember, it's plus, so it's 1 left. And up 68. And she just says to go up 75.1. You can type these into the calculator, and both graphs are going to be really super close to the data, and you can like decide for yourself what you think is better. That's kind of the deal with this one. So basically, you got to remember inside the parentheses that +1 means actually left 1, and then outside the parentheses up 68, up 75. All right. That's what's going on here. So now we have, talking about the pumpkin and the catapult again. So this one's been shifted over to the right 5 seconds. So the t minus 5 inside the parentheses moves it over right. All right, this here is very similar to what we just did in section 5.2. It says here's a graph of f and g, express g in terms of f. So you're say g of x is equal to, well, how did it move? You know, is it plus, minus, whatever? So g of x equals something with f of x over here. This is the leaving school, driving, all that kind of stuff. And we talk about, like, you know, this is going to be left or right, 60 minutes. I believe it's 60 minutes. This one here, you're moving the data, moving the equation to fit the data. We talked about that. So here's the original, starting at 25, right? You can see it's starting at 25 right there. It's growing by 19% per decade. So we're going to make it, we got to shift it up. So what can we do to shift it up and make it match the data? Okay. So here's a graph of y. All right. Sketch the original. Okay, so this has been moved left 2 and down 1. So this is left 2 and down 1. That's what we have here, left 2 and down 1. We want to graph the original. So we're going to graph the original. We got to do the opposite of both of these things, because that means left 2, down 1. So the original would be right 2 and up 1 from this. So this is the result after shifting it left. So you got to move it back to the original spot. So just pick a point, like, I don't know, over 3.5, up 5, like pick that spot. Move it right 2 and up 1, and that would be the original, back to the original graph. This is the two examples here that are like repeats. It's like how is it shifted, all that good stuff. All right, so this is lesson 5.3, just the skeleton of it to get you through.